Single criterion decisions with multiple uncertainties using decision trees and D-zone maps. J&J Pharmaceuticals are developing a new drug for the treatment of diabetes, thrombosis, and cholesterol. However, J&J can invest only in one of these projects. The cost of pursuing these products, for the preliminary test, it would spend $2.5 million, and for the FDA approval, there would be a cost of $500,000. The marketing department has arrived at potential revenues from these projects. Here too, there are some uncertainties. There's a potential for high revenue or low revenue. For example, for cholesterol, the high revenue would be $13 million, while the low would be $7 million. Uncertainties facing J&J now. Will the preliminary test be successful? Will the FDA approve the new drugs? Will sales generate the projected revenues? The question for J&J is which product? We can start with a 50-50 assumption for all uncertainties and then study the impact of such assumptions on the final decision. Action plan. First, draw the DT sketch, then develop the Excel model, then plot the D-zone map, and finally study the uncertainties. Here we have the sketch for the decision tree. We have three options, and let's focus on thrombosis. If the preliminary tests are successful, then we proceed for FDA approval. And if FDA approval is granted, we proceed to market, and there is a potential for high revenue or low revenue. Similarly for the other two projects. Now to step 2, where we build the Excel decision tree, and in this case, it is for the preliminary tests. Once we complete the decision tree model, with one click, we can create the D-zone map. The model creates 3 zones for the 3 decisions: thrombosis, cholesterol, and diabetes. The zone in which the red pointer lands is the recommended decision. Here we have 3 axes. One is for diabetes, the next is for cholesterol, and up here is the thrombosis. When I change the probability of success, the decision is thrombosis. If I change the probability of thrombosis success to 70%, again the recommendation is for thrombosis. What is important to notice is the distance of the pointer from these demarcation lines tells you the degree of freedom you have with regard to your assumptions. In this case, when the probability of diabetes success drops below 46%, the decision should be for thrombosis. Zone map such as this gives you tremendous flexibility to understand the sensitivity of your assumptions to the final decision. Could you have made better defensible decisions relying on common sense alone? Probably not.